Right, good evening everybody and welcome to this evening's webinar on Woodlands and Climate Change. My name is Martin Glynn, I'm an associate at RDI Associates and will be hosting this evening's webinar along with the speaker Will Richardson. As just mentioned, if you could please leave your microphone on mute whilst the speaker is on. We will then ask you to unmute yourself if you do have any questions. Please, if you could put those in the chat function. And we will come to you at the end of the session to ask you to unmute yourself and ask a question at that point. If you don't want to ask it yourself, just let us know and we'll ask it on your behalf. And as just mentioned, we are recording this webinar, making it available online. We will send you a link to that with the invitation for next week. So as mentioned previous weeks, if you've been here before, you'll know all this anyway, but just briefly, RDI Associates Limited is a forestry and project management delivery company working across a wide range of sectors, not just forestry, but renewable energy, training, climate change, etc. And this evening, there's Will Richardson, the director of RDI Associates, myself, both of us are members of the Institute of Chartered Foresters with quite a lot of experience in the sector. Will be speaking most of this evening. So, and this evening's webinar is part of the Woodland Management Focus Area Pilot Project, which is funded by the Forestry Commission through the Woodlands and Management Forestry Innovation Fund. What we're doing through the project is identifying clusters of unmanaged woodlands using geographic information systems, running a programme of woodland webinars, such as this evening's, and then offering support and advice to landowners in the focus areas or clusters that we've identified on the maps, and we're going to be starting that this week. In fact, Will and I were just talking earlier on about those areas. We'll also then be undertaking an evaluation of woodland status against the United Kingdom Forestry Standard, which we talked about in one of our earlier webinars. So I'm now going to hand over to Will and ask him to speak about this evening's subject, forestry and climate change. Will, over to you.
Thanks very much, Martin. Hi everyone. Thanks for joining us this evening. So yeah, forestry or woodlands and climate change. It's again, as we've found in this series of webinars, we're looking at quite a large topic here. Obviously, this incorporates not just woodlands, but the climate in general, and how that climate is changing and how it affects not just woodlands, but everything around us. We're going to focus on some key points here, and there are certain elements that are quite technical, so apologies for that. We'll try and cut through those as best we can and leave you with some very hopefully high-level messages at the end of the presentation, which maybe you can look into a little bit further and possibly apply to your own circumstances. So we're going to talk about how climate change will affect soil moisture and soil nutrient regimes, and how this also may, the changing climate may affect the occurrence of key pests and diseases. And then we're going to spend a bit of time talking about resilience, species selection, and access to other online sources of information, advice, and guidance. Some of these themes will be familiar to those of you who have joined us on previous presentations. We've spoken about the UK Forestry Standard a lot in our series of webinars. We're obviously looking at, in particular, the forest and climate change section of the UK Forestry Standard in this webinar. And we've adapted this series of slides from our Lantra Awards approved forestry and climate change course. So as I say, there's not a lot of time here. I don't want to talk the whole webinar, and we very much welcome questions from you as well. So we'll have plenty of time from that. So mitigation, let's just think about these definitions to set the scene. Mitigation, so the adjustment in natural or human systems to a new or changing environment. So we'll be looking at examples of mitigation in terms of woodland management. And then we'll also be looking at examples of adaptation and protection. So this is a human intervention, our intervention to eliminate or reduce risks associated with climate change. So this could be part of your management planning process, how you adapt those management prescriptions that you might apply to changes to your woodland that might be climate change driven, such as incidences of pests and diseases, droughting, waterlogging, etc. How you might decide on your species selection, and looking wider, just outside of your own woodland boundary to the adjacent sort of wider landscape, connectivity and environmental protection. So some references in here, slightly out of date, but they're still relevant. So there was something called the Reed Report that was written in 2009, which was a very comprehensive document discussing the impacts that climate change could have on our trees and woodlands into the future. And it set out some key issues. So changes to growing conditions, altered cloudiness patterns, extended growing seasons, modified soil moisture patterns, and altering soil nutrient availability. These are all key themes that this report brought out. Others included things like changes in physical disturbance and biological disturbance. By that we mean increased incidences of windiness, which we've seen a lot of in the last couple of months, and biological disturbances. Biotic means are pests and diseases. So this report was pretty thorough in how it set out these changes or predicted changes to our woodlands as a result of climate change. And we could look at, let's say, one particular scenario. Let's say a central UK region. We're looking at a high emission scenario into the future, 50 years time, how the temperature might vary, how it could be higher in both winter and summer. So potentially 5 degrees higher in summer, which is very significant. Again, rainfall patterns changing, higher in winter, significantly lower in summer, 50% lower in summer. That would be very significant. Reduced snowfall, higher wind speeds in winter. Well, we've just witnessed that happening again over the last couple of months. So this then starts to affect things like soil moisture, and I'll talk about that in a second. Lower humidity, lower cloud cover, higher sunshine hours. So these are all significant changes that could happen in the future. And the impacts of these changes. So what would the impact of rising temperature have? The impact on phenology, the advancement of 3 weeks of leafing date in oak since the 1950s. 3 weeks, that's quite significant. Now, since the 1950s, obviously CO2 and other greenhouse gases have increased since then. Will that accelerate further? Will we see, this early leaf breaking dormancy even earlier as we go into the future? Rising concentrations of CO2 could have this growth stimulating effect on tree photosynthesis, but it will also affect other elements of the tree physiology, such as faster growth rates may result in nutrient deficiencies or imbalances, and how precipitation and seasonality might be affected as well. So enhanced rainfall in winter and spring, greater risk of either winter or summer flooding events, and wetter winters may increase waterlogging, and so on. Just some examples there of the impacts of these changes to our climate. So we start to talk about water availability and seasonality. So is there going to be a greater likelihood of things like spring drought, how that might affect, for example, planting season? I'm, as a forester, already slightly concerned about, risking planting trees beyond mid to late March. So we've seen quite dry springs over the last few years. Maybe that we have an incredibly wet spring this year. But again, things worth bearing in mind. Do we need to plan for our restocking slightly earlier than we would do normally? Is there going to be greater likelihoods of summer droughts? So are we looking at choosing species that may be better able to cope with occasional drought? And then I mentioned earlier abiotic stress and biotic stresses. So here we're looking at, again, these high temperatures, droughting, flooding, wind risk, and possibly increase of wildfires as well. So how are we going to respond to this? What's the information that we can use to help us look at our woodlands and start to think about those key themes of adaptation and mitigation? Well, the first thing I'm going to talk about here is the ecological site classification for forestry. So this can help us decide on the suitability of tree species going on into the future. I'm sure a lot of you are already familiar with this system, but it's useful to understand some of the background to it and what it bases its findings on. So it's computer-based. You can access it via the internet, and it's free to use. You need a location of where your woodland is, and based on that, it starts to calculate species suitability. There are other parameters that you put in as well. I'll talk about those in a second. It'll also give you things like wind damage risk status under what's called forest scales as well. And this is helpful for our planting decisions. So what's behind this tool is the three principal factors of climate, soil moisture regime, and soil nutrient regime. So what do these mean in reality? So climate we know about, but what does soil moisture regime mean? Well, this is essential for plant growth. What this does, it expresses varying availability of water throughout the year. And it concerns oxygen availability for the respiration of roots, obviously critical to the survival and you know, how that tree will thrive in those particular conditions. And of course, that soil moisture regime is influenced by climatic, topographic, and soil conditions. Okay. So there's different classes used in the decision system, in this ecological site classification decision system, and they vary from very dry through to very wet. And these soils that can be almost too dry or too shallow to grow trees, and those which are permanently waterlogged, again, not suitable for growing trees. So you want that happy medium somewhere in the middle, not too dry, not too wet. So from very dry to fresh, these classifications in the system, there's good aeration, so soils are never so waterlogged as to impair root function. And then we've got very moist to very wet. So the main problem here is waterlogging, and the wetter classes will only relate to trees with shallow, widespread rooting systems, so willows, boulders, etc. And you can also fine tune the tool. So the more information you have about your soils, the better the results will be from the tool in terms of the species suitability that you get the report at the end of it. So you can fine tune it for soil texture, stoniness, rooting depth, aspect, slope. So the more information you put in, the more accurate the result is that you get. So soil nutrient regime expresses the availability of soil nutrients. Now, obviously, this is directly related to soil moisture regime. The most important nutrients that we're talking about here are nitrogen, phosphorus, potassium, calcium, and magnesium. And of course, soil pH will affect the plant's nutrient uptake. So again, if you have an understanding of the pH of your soil, again, the more accurate and useful the list of species will be at the end of it. We tend to make less use of fertilizer in current forestry terms. I've not had any experience of applying fertilizer to woodland creation or indeed restocking sites for a long time. Often it will be applied to brownfield sites, particularly where you are planting new, if there's serious nutrient deficiencies within those brownfield site soils. But tending, if you are looking at restocking areas of your woodland or wanting to select species to, let's say, do enrichment planting, then you're probably not going to go down the route of inputting fertilizer into the system. And I would always try and choose species that don't require inputs of fertilizer. And obviously, if you do, you are looking at inputting fertilizer, then of course it's best to avoid inorganic fertilizers onto the land wherever possible. So factors affecting nutrient availability. So again, we've got these classes, as we had with the soil moisture regime, from very dry to very wet. We've got these classes that affect nutrient availability as well. So there's 6 classes within the tool, from very poor through to carbonate. So these are soils with very high pH and often relate to arid and semi-arid areas. Of course, we don't really have those in the UK, although possibly it could be argued that very eastern points of East Anglia could fall into that semi-arid areas in certain situations, but certainly not here in Yorkshire and the northeast. Supply of nitrogen is important, and the lack of nitrogen or an inability to access organic nitrogen, which is bound within the soil, can be a key issue. And on deeper peat soils, potassium may be in short supply. Now, we don't plant on peat soils. That's something that was done in the past and is not done these days at all. Obviously, peat is incredibly important for carbon, and also they're often found on other priority habitats, moorland, etc. So we avoid planting on peat anyway. There is possible for there to be excessive quantities of one nutrient which inhibits uptake of another. For example, high concentrations of calcium in shallow soils underlain by chalk could inhibit the uptake of phosphorus, for example. I don't want to get too much into the chemistry. It's probably a little bit beyond my knowledge anyway, but these are considerations as well. And it's something that the tool will pick out if you put in detailed information about your soils. So assessments of moisture and nutrient regime. So we can usually distill this down to good information about your soil. So all that technical blurb I've just gone over. So the more you can understand your soils, the better. So I would certainly try and find out the soil type, its pH, and its depth. Now, we'll introduce some tools towards the end of the presentation where you can find out information about soil type and pH. They're free online resources that you can look at, put in a postcode or a grid reference and find out some information about the soils that are there. But it's always worthwhile going out with a spade, digging a pit, looking at the depth of your soil, looking at the organic content within this, the humus that's in there. That'll tell you a lot as well. So we've touched on these, weather patterns, moisture, nutrients or humus I just mentioned, and then other tools that you can use to help you understand your soils are indicator plants. What plants have you got growing in your woodland already? Some will be very specific to the soil type that's there. And there's this Forestry Commission Bulletin 112, which is the National Vegetation Classification. And that's well worth a look as well. That will also help you, give you information about your soils through what vegetation either is growing, what you've identified, or what you could expect to grow. So here are some of the tools that I mentioned. The Soilscapes, Geology Viewer of Britain gives you information about the underlying geology, and it's also useful to understand that as well. So we've discussed some of the technical aspects behind this tool that we can use to help inform our decisions, but I would certainly do a bit of research anyway, regardless of whether or not you use the tool, about your soils, and that will help feed into your management planning processes. So let's talk about species selection in a little bit more detail. What is provenance? What's origin? What are natives? What do all these mean? So we've got native trees, obviously here to the British Isles, and exotic or alien trees, which aren't native to the British Isles. Whether native or exotic, provenance is where the seed has grown and been collected from. So that's what provenance means. Origin is the natural range of species from which the material originally derived. So the origin, for example, you could have spruce trees growing in your forest, and you've got they're seeding, they're providing seed, but the origin is obviously elsewhere. Obviously with spruce, it's Northwest America. Therefore, a tree, native or exotic, may have a local provenance but a distant origin. Okay. The list of species that we currently have, particularly in this tool, this online tool, will change as more research on more species is done. But, for example, experience with certain species, such as eucalyptus, shows that ideas are not necessarily fail-safe. So I've mentioned eucalyptus there because, you know, in a changing climate, it may become more suited as our climate warms up. But if we do get cold snaps and long cold snaps in winter, then that particular group of species can suffer significantly and can die. So there's still risks associated with that. So nothing's fail-safe. So we also start to think of things like, well, as we get larch disease, as that spreads more frequently, and of course it has this deciduous canopy, what can we plant in place of larch? Well, what's suitable to say, okay, larch, particularly let's say grown on ancient woodland sites, doesn't affect the ground floor as much as a much denser shading canopy, for example, spruce. So what could be planted in place of larch? So again, these are things we need to think about. Sycamore, does it occupy the same niche as ash? Will its greater shade be an issue? And additionally, ash will tolerate wetter soils better than sycamore. So again, nothing's fail-safe. I mentioned there red band needle blight affecting Corsican pine and a lesser extent Scots and lodgepole pine, but are there other pine options out there that we can consider? So again, more research goes on, more species will be added to the list of suitability. Okay, again, I don't want to get too technical with this. I'm afraid it is quite a heavy subject, but it's just some of the sort of underlying key messages and themes that we want to introduce. So the limitations of the model is that it is a knowledge-based model. So at the moment, it's knowledge on what's currently known. So as I said, as more research is done on more species, so that list will grow. And of course, it needs to be kept up to date, changing incidences of pests and diseases. Again, so there are limitations to the tool. But for everyday use, I would certainly recommend having a go at using it and familiarising yourself with how it works and how it can help you with your woodland management planning processes. So just a quick bit about pests and diseases. We'll talk about invasive non-native species and how climate change may be accelerating this, and give a couple of case studies on pests and diseases as well. So when considering pests and diseases, we want to be thinking about our species and provenance choices, whether we're going for native or exotic species. Do we need to consider things like genetic resilience? Genotype showing heritable resistance to pests and pathogens, and a more diverse range of species. Things like underplanting to supplement natural regeneration. Again, we'll come out with some key bullet points towards the end of the presentation in a minute or two. So what are invasive non-natives? The term non-native invasive do not necessarily mean the same thing. Non-native species are species introduced by humans outside of their natural or native range. Invasive non-native species cause unwanted environmental or social impacts by spreading rapidly and becoming very abundant. And as no doubt you'll all be aware, once you've got them, they're very hard to get rid of. But some competing plants may be native, so it's worth bearing that in mind. So the effects of non-native species, invasive non-native species, they can grow more rapidly than, let's say, our native species. They can utilize otherwise unexploited niches within our woodland. They could be a vector for tree diseases. So a classic is rhododendron as a vector for Phytophthora. And they could affect our tree establishment and woodland biodiversity, definitely. So a good example of that is Himalayan balsam, a very aggressive and successful competitor for light, nutrients and water. Pretty much nothing else will grow underneath it. And of course, it's going to cost us money indirectly or directly to deal with this. So dealing with our invasive non-native species and or competing vegetation. So again, I introduced this concept of understanding your woodland intimately, undertaking this constraints, opportunities and threats assessment. So again, monitor and understand your site as well as you possibly can. Where is this particular invasive non-native species? How is it affecting your woodland? How would restocking or natural regeneration, how are you going to implement this, bearing in mind you've got these invasive non-native species there? Okay, I'll come back to Himalayan balsam as a good example. Might that make it difficult to rely on natural regeneration to restock your site? What will you do to control it? Yeah, you've got to start to allow for appropriate establishment maintenance. So cutting, pulling, again, extra cost, extra time. Are there things like pre-planting and or early control or eradication that you can do? Let's say, for example, before you thin your wood, you know you've got Himalayan balsam nearby, it's not yet in your wood. Maybe go and pull that balsam up, or have a word with your neighbour, that kind of thing. So preempting any spread. So again, that's understanding your local or national picture. And yeah, light control, this is key. So we touched on thinning in one of the previous presentations and how that control of light is so important to the woodland, particularly woodland biodiversity. But there again, you might be encouraging ideal growing conditions for things like Himalayan balsam to thrive. And edge effect, again, this is this light issue, particularly in small blocks of woodland where you're letting lots of light coming at the edges, and that again can encourage your invasive non-native species to thrive. So a couple of case studies. Here's the great spruce bark beetle, Dendroctonus micans. Damages spruce trees by tunneling into the bark of the living tree to lay its eggs under the bark. It creates these bleeding wounds, obviously affects the timber quality and can kill the tree. There is an effective control for this species, something called Rhizophagus grandis, and the primary contact there is Forest Research, and they can help you with that. Good thinning as well, letting light in and letting cold into the bottom of the woodland in winter. That can also reduce the spread of this particular pest as well. Another case study is obviously Phytophthora. We're starting to see this spread more on the east of the Pennines now, which is sad but predictable. I think we've all anticipated this for a number of years now. there's not a lot you can do once it's in. It does spread quickly and does kill the trees quite quickly. So mitigation is basically not to plant larch. Obviously, you don't encourage larch regeneration. And if you do have the disease, you will get a serve the statutory plant health notice to fell the infected trees and those immediately adjacent to it. Other things you can do if you've got rhododendron, it's advisable to cut that out because, as we discussed earlier, it is a vector of the disease as well. And of course, good biosecurity can help prevent the spread of the disease too. So here we go. Here's our standard biosecurity slide. We've seen this before in previous presentations, but it is important that we all sort of embed this into our practices, into our woodland management practices and operations. Basically, the best thing you can do with biosecurity is if you are traveling from site to site, is remove mud and vegetation matter off your shoes and boots. Simple washing in a bucket will do that quite effectively, and so much the better if you can use some kind of a disinfectant as well. So in summary, these are hopefully the key take-homes from this presentation. And as Martin put in, no regret options. So some steps, as it says, for climate change adaptation involve more significant changes to current practice than others. However, there are a number of basic measures that require little change to best practice and should be considered as these no regret options. So species mixtures will provide insurance against climate change. Not all will be affected to the same extent. Not all those, if you're putting in a mix, not all will be affected to the same extent. Some may be more prone to droughting, some may be more tolerant to droughting, and so on. Provenance mixtures will provide good insurance as well. Sourcing your tree stock, maybe if you want to restock with oak, maybe look at sourcing those oak trees from further south. That provenance may have been used to slightly drier conditions, and let's say provenances that have been sourced from further north. Tree species and woodland types should be well matched to the site. So this is where the tool kicks in. We're understanding our soils, lots of information on that will allow us to get a report that will set out what tree species would be suitable to our site given different climate change scenarios. So here we go. Climate change predictions should be considered in the choice of our planting stock, which is what the tool does for us. And at a landscape level, larger, better connected woodlands should be an objective. So again, look around you. What other woodlands are in the landscape? Is there any way that the connectivity can be made, allowing species migration, increased resilience within your woodland? And I've just put in a last bullet point there is age irregularity. So different age classes within your woodland can also help make your woodland more resilient as well. So quite a lot to consider there, a lot of technical information, I'm afraid, but hopefully it gives you an introduction to some of those key points. And here's a list of further sources which we'll make available to you. So there's a link to the tool there, the ESC decision support system, and there's other useful bits of information there. The soilscapes site I mentioned, obviously Met Office for climate information, and then there's great information on Forestry Commission and Forest Research websites as well. Before we go to the Q&A, I'll just remember to plug next week's webinar. So this is an introduction to management planning, and particularly focusing on setting objectives and planning operations. And again, we'll tie everything into that webinar next Tuesday. So that's me. Hopefully you've got some questions, Martin. I'll let you introduce also.
Right, thank you very much, Will. Also, just before we go on to questions, we have a sort of spare slot in the calendar in 2 weeks' time, Tuesday the 15th of February, for topics which you might want to talk about, either new ones that we haven't talked about to date or something that we have talked about you'd like to cover in more detail. We did have a couple of spare slots. That was always the intention to do that, but well, in fact, more than a couple. But I'm afraid Storm Marwin took up one of those. And then we've also put in a diary date to talk about something called My Forest, which is a management planning online tool which brings together everything we will have talked about during these Woodland webinars. And like Will's talk next week on management planning, we'll have a section on climate change and how that sort of impacts on your woodland management. So if you have got any ideas about things you'd like us to talk about on the 15th of February, do please let us know. Either email Will or message us or reply to Erica's email when she emails you about next week's webinar. So okay, so any questions and answers? At the moment we've just got a couple left, both from Mark Corner. Mark, if you'd like to unmute yourself and ask your questions. And if anybody else
Thank you, Martin. Thank you, Will. Yeah, my first question is about the relationship between the National Vegetation Classification and the ESC. I mean, do these systems sort of talk to each other, or are they independent? And then my second question is, if your objective in planting a woodland is to help mitigate climate change, is it species dependent? Are some species better than others at collecting more CO2 and doing more good for the climate emergency, or are they all the same? Thank you.
Thank you, Mark. Very good questions. Yes, the online decision support tool does obviously reflect the sort of data that's in the NVC, the National Vegetation Classification. I don't know the exact ins and outs of the full data sets that operate behind the decision support tool, but it certainly does reflect that information, that NVC information. In terms of planting objectives, another good question. I suppose ultimately, what do you want to achieve? If you want to try and sequester carbon quickly, then obviously you want to be looking at fast-growing species. Again, it's really good, the decision support tool, to show you that, what species are going to be really suitable. And obviously, fast-growing species that come to mind: spruce, alders, willows, that kind of thing. Obviously, on fertile brown earths, they're going to grow pretty quick, and then obviously on porous soils, they're not going to go so quickly. If you have other climate-related objectives, such as maybe water-related objectives, flood mitigation, then you would be wanting to design your woodland in a way that increases, I think the term is hydraulic roughness. Hopefully there's somebody on the call this evening that might be able to explain what hydraulic roughness is a bit better than me. But there's obviously various elements here. Of course, it's always a consideration as well that you are growing trees for timber that would enter into the timber supply chain, and that timber will obviously be, let's say, used in construction, and therefore that carbon would be locked up for a long period of time, and certainly much better in terms of its carbon balance than the alternative construction materials such as steel and concrete. So there's quite a lot to consider in that question.
There's not a sort of hierarchy of species that are best for the climate.
Again, there may be. I did see. Is Crispin still on the call, Martin?
Yes, he is.
He is. I might pick on Crispin if I may. But I would say that if you wanted to sequester carbon quickly, then you're looking at fast-growing species, and it may be Sitka spruce, it may be alders or willows, depending on the site. Some of it's going to go quick and sequester lots of carbon, but bearing in mind, if your objective is to sequester carbon and do nothing else, then you won't be cutting it down to burning it in a power station, because you're just releasing that carbon straight back out again. If your objective is to say, well, actually, I want to grow wood and leave it in perpetuity, then you could possibly achieve the same amount of carbon sequestration over a longer period of time if you planted native species. So birch, again, older, and just let them grow, not do much with them at all. And actually, if you interrogate something called the Woodland Carbon Code, then you can get similar carbon sequestration figures between, let's say, a hectare of pure Sitka spruce compared to a hectare on a short rotation compared to a hectare of native woodland across a very long rotation. So in terms of a hierarchy, yeah, I'm afraid I'm going to use the get out there. It just depends what you're growing for.
Yeah, I think I'm glad you mentioned the Woodland Carbon Code there, Will, because it's something we haven't mentioned much to date. But it's if you do want to sort of look at this subject, if you just Google Forestry Commission Woodland Carbon Code, it will tell you the information on that. You know, there's basically the Woodland Carbon Code is around you know, assuring woodland creation schemes, and then in terms of the amount of carbon that woodland can sequester. And you know, clearly in most circumstances the same would apply in terms of woodland management if you're restocking and the like. I think the important thing to point out there really, Mark, is that you know, what is the right answer for maximising carbon sequestration is, you know, as Will said, isn't necessarily the right answer for climate change resilience. Probably from the point of view of sequestration, you would plant all of one species, you know, the fastest growing species on one site, but that's certainly not something that we would recommend, or I think certainly in terms of most you know, grant schemes, and certainly for UKFS, something that wouldn't be allowed. What you need is resilience, and in order to get resilience you need diversity. So it is a mixture of things really. So yeah, so I could pass over to Crispin if you don't mind. Are you there, Crispin? I don't know whether you're still...
Yes, I'm here, and I put my virtual hand up.
Yeah.
I don't know if you can see that, but I was just going to quickly respond to the kind of previous question in a way initially, just to say that I think the start point with any kind of woodland creation scheme, in my mind, has to be centered on the kind of owner objectives, understanding what does the owner, what are they trying to get out of their kind of woodland creation scheme, and then that has to be matched to the site, you know, the potential of the site and the constraints and opportunities it holds. So I think it can be dangerous looking at single issues just as carbon alone, and as Martin and Will have flagged, you know, the Woodland Carbon Code provides you with a kind of auditable, verified amount of carbon that can be locked in different woodland types. But ultimately, it depends on whether you want to have that carbon on the site, as in locked in the trees on the ground, in which case some of those native schemes that are non-intervention will give you higher locked carbon. But if you're trying to make a return and make some profit from the woodland, then having a mixed productive woodland that's having removals through thinnings and clear felling will potentially be addressing the climate change issue through product substitution, but the actual carbon locked on the site will be impacted by the thinning regime that's being undertaken. So I think the key message, and Martin's touched on it, it's that resilience, because obviously you know, climate change is a kind of long-term challenge, and if your woodland's not resilient, but it's just based on a single issue, such as trying to lock up carbon quickly, it can result in potential challenge. And the question I posed, and grateful for thoughts around the virtual table, was, as a sector, do we feel we're kind of moving fast enough to kind of recognise the challenges of climate change, or have we got a reliance on our knowledge of the existing species that are doing well at this particular point in time? And I think there's kind of two scenarios. One, the kind of productive coniferous scenario, where we've still got a strong preference towards a relatively narrow range of species. Sitka spruce springs to mind, particularly in the kind of northeast. But also with some of our native woodlands, we've been focusing on NVC classifications and creating, you know, as an example in the Yorkshire Dales, upland ash woodlands that are now under quite a significant amount of threat because of cholera. And it's because those NVC woodland classification types are in some ways historical, and I think we should be looking to build greater resilience into our woodland design through species diversification and making sure we're looking forwards as well as backwards. Thanks.
Yeah, thanks, Crispin. Yeah. I mean, I don't know whether there's got any comments on this. I mean, I feel and felt for quite a long time that as a sector we're too reliant on small number of species, as you said, Crispin, and I think that in particular with climate change and all the impacts around, you know, plant health, the tree diseases and what have you, then you know, again, diversity is the key word there, really, and we absolutely need to ensure that we have a really good diverse mix of species, whether that's native, non-native, near natives, as we call some of them these days. You know, I think ultimately, as you said, Crispin, it comes back to owners' objectives, site types, all these sorts of things. You've got to have the right species on the right site, but you know, notwithstanding that, yes, we need diversity. So whether that's in a new woodland you're creating or managing your existing woodland, you know, if you've got a woodland of your own and it's all one species, as Crispin said, you know, if you've got something that's all ash or all larch or all something else, then you know, you need to be thinking about bringing in other things. So, any further thoughts about that? Well, have you got any thoughts on that issue?
No, no, nothing to add to what Crispin and Martin just said. Just Crispin, just for possibly my own benefit, hydraulic roughness. That term is familiar to me, but perhaps I don't have the knowledge to fully explain that. I can't leave that one hanging.
No, happy to step in, and I probably should have introduced myself, just for those of you that don't know me. Crispin Thorne. I'm the area director of the Forestry Commission for Yorkshire and the North East, and I'm incognito with my ICF Zoom background, ready for an event tomorrow. So I haven't managed to change that. So whilst I am an ICF member, I'm not here today representing them, but I will be tomorrow if you're interested in water, because we have got a UKFS water seminar tomorrow, which we'll be running in partnership with the ICF. And hydrological roughness, it's just really, it equates to the speed that water travels through a catchment. And I suppose in its extreme, if you've got a hard surface like a concrete road or a drive, you know, there's very little hydrological roughness and water travels over it very quickly. So it can kind of move from the top of the catchment further down the catchment and flood, you know, communities. While as if you increase the hydrological roughness by changing the vegetation management, and you know, things that have got the most hydrological roughness are woodlands that are got you know, well established and maybe have got a shrub layer, but basically it means there's quite a lot of intersection. So when it rains, it can't quickly move across that land into the drainage systems and down into the wider catchment, creating floods. So part of the desire is to understand how water flows through a catchment, identify those areas where you can slow it down through changing the vegetation type from perhaps you know, improved grazing, which has got a lower level of hydrological roughness than a woodland. And that's one of the reasons why they recommend a slightly, you know, a higher stocking density for woodland that you're creating for water objectives, just because it increases the number of physical barriers in the system to slow that water down. And I suppose the other factor, as well as hydrological roughness, is the interception, so the root systems and the ability to get water to penetrate into the soil systems is aided by woodland creation as opposed to other types of vegetation. So not only does it slow it going across the land, it also helps it infiltrate into the soil horizon, as it were. Thanks.
Thanks, Crispin. That's really helpful. Yeah. So we've just got one other question, which actually is a really good sort of specific example. Oh, another question just come in actually, so we'll take that one as well. But just the previous one was a really good example of you know, what we talked about earlier on, and a specific example. JP has asked about whether coppice chestnut is good for carbon sequestration, and it's sort of putting into practice what we've just talked about, really. Ultimately, you know, as we said, it depends really. If it's fast growing on that site and it's suited to that site, and you know, sweet chestnut does tend to have some quite particular site characteristics that it requires, then yes, it can be. But you know, just as importantly, you need to be thinking about what's going to be happening to that chestnut once it's, you know, coppiced and used. If you're putting it, you know, straight on the fire as firewood, or chipping it into a boiler, then clearly the carbon cycle is going to be that much shorter. Whereas if it's being used for fencing or cladding or something, and then at the end of that being used for firewood, then the carbon cycle is extended, and therefore the sequestration effect is that much greater. So yes, it can be, and it just depends. But clearly, what you don't want to be doing is growing coppice chestnut on a site which is unsuitable for coppice chestnut, because in that sense you won't be getting good sequestration, and there will be other things you could do that's better. So
it's possibly worth mentioning to JP about the vulnerability of sweet chestnut to phytophthora as well.
Yeah, absolutely.
So it's just worthwhile mentioning that, JP. I think you've raised a couple of questions about it previously, and this is where things like your thinning, application of thinning, or reintroducing coppicing, varying your height and age structure within that coppice plantation should all help to improve the resilience of that to things like pests and diseases. So exactly what we've just covered in the presentation would certainly apply to that, your single species plantation. And just think about, how do I make that more resilient?
Great. Thanks, Will. Just finally, and I think we'll make this the last question because it's 5 to 6, sorry. Got you all unnecessarily relaxed there. Brian, if you're there, if you'd like to unmute yourself and ask your question, are you around? We can ask the question for you if you want. Okay, right, we'll ask that one for you. Brian's saying, I hear that newly planted woodland would take 25 years before it becomes a carbon capture woodland. Will, have you got any thoughts on that?
It's a good question. It's a valid question. Yes, newly planted woodlands do take a while before they become a carbon capture woodland. You've got to take into consideration the carbon that it's taken to prepare the site, protect it, fence it, grow the trees, protect the trees. But it does vary, that period of time. 25 years does sound long, but it can be a number of years before that woodland becomes positive in terms of its carbon sequestration. The Woodland Carbon Code effectively is the place to look for exactly how long it will take, based on the species you're planting and all those different variables. So protection, maintenance, ground preparation, all those will impact that time period. But you are correct that there is that period at which, it's a negative, essentially.
Thanks, Will. And again, it just comes back to this thing about choosing the right species for the right site, because the better suited they are, the quicker they will grow, and the sooner any woodland will become carbon positive rather than carbon negative. As we'll outline there, for all sorts of reasons, woodlands are in their early stages don't grow as fast and therefore aren't sequestering as much carbon. But that's taken account of in things like the Woodland Carbon Code and the Carbon Guarantee, which is something else we haven't mentioned much. And allowed for in terms of the phasing of when carbon units can be claimed, etc. So
it's worth thinking, when you first stick your little tree in the ground, it's a tiny little thing with very fragile roots, and it's basically the first few years it's fighting for survival. It is a battle. It's a battle for everything: water, nutrients, light, and it's putting all its effort into that survival and getting its roots established and out competing whoever its neighbors are, grass, weeds, other trees. That's why they don't grow very quickly in the first couple of or 3 years. And then once it's established, its roots are down, they start to accelerate away. And obviously the weaker ones that just don't have the fight in them basically will die. Will wither away and die. And of course, as Martin say, it's suiting the species that to the site conditions will ensure you get maximum success, and obviously looking after them Yeah. In those early years. It's so critical.
I think it's also just worth mentioning, given that the subject matter of the series of webinars is the management of existing woodland. But of course, existing woodland, which is managed, will in many cases sequester carbon faster than unmanaged woodland. Often an unmanaged woodland will have reached a peak or near peak production in terms of the amount of carbon it can actually sequester. The trees will have, because of shading and site productivity and various other trees, the trees will have started to slow down very much, and in some cases stop growing. Whereas if you were to start thinning them out and clearing areas and things and allowing the existing trees to regrow that much more quickly, then from the point of view of carbon sequestration, you will increase the rates again there. So another reason to manage your woodlands. So. Good. Okay. Well, it's 2 minutes to 6, so I think it's time we all headed off. Thank you very much to Will. Thank you for Crispin there for your interventions as well. That's very helpful. Hopefully we'll see you all next week. We're talking about management planning. Will's going to use an example from a sort of a real site as such. So not a PowerPoint presentation, but more of a, looking at some particular examples and some maps and all those sorts of things. And we're bringing together everything we've talked about today, including this evening's subject of climate change. So if you do, please look out for the invitation from Erica that will be coming out next week. Thank you everybody for your time. Good night and see you next week. Bye-bye.